Hello and welcome back to the workbench. Today on the workbench we have something else to work on. Should be a Nintendo Switch in here. The original Switch, not the Lite. That does not work. And I got this over a month ago and just haven't had time to look at it. So we will get our first impressions together at the same time. Come on. I know you're in there. Ah, finally. This is supposed to be another no power, no charge switch. And I bought this one because it looked like it was in reasonably good shape. I do see some scratches on the screen now, though, that I've got it in my hands. Okay. Back doesn't look too bad. And it looks like it has those screws, all the screws in it. Nice. Doesn't appear to be bent. Let's just see if she will draw any current off the USB. Absolutely nothing. How about here? Nothing. Okay. Let me get a look down in this port. Really can't tell. Let me get another microscope so we can get a good look down in that port. Yeah, there's definitely some corrosion going on in there. I wonder if this is going to be a liquid damage switch. Well, let's see if we can get inside this, shall we? Okay, we got her opened up and give you a good close-up of how she looks inside. Not bad. The moisture sensor does not look like it's been wet. Don't really see any signs it's been worked on before. Not yet. So yeah, it doesn't look too bad. So let's do some checks and see if we can figure out why it's not drawing any current when we plug the USB charger in. Well, here's our old friend, the M92 T36 chip. I have to suspect it first, of course, because it is a source of quite a few power-related problems with the switch. Let's just see if we have any shorts on these capacitors around that around the top of this IC, like right in here. No, no, not shorted. No. Let me try it. That was with negative on ground. I'm in continuity mode. 357 ohms. 517. 357. How about over here? So that's ground. What about right here? And what is on my probe? Okay, right here. Something's still on there. And 421 ohms. All right, so nothing dead shorted yet. Okay, is our fuse good? See if I can get that in the shot. Fuse is good. Fuse seems like is always good. Our coil intact here. Yes. How about some check for shorts around this BQ chip. Nothing obvious. Go through these. Well, go through these again. Nothing obvious. Nothing obvious when we look around in here either. Okay. Let's try applying some voltage. And I want to measure right there on those capacitors. Should be, I think it's 1.5, and then there's like a 2.5. So let me connect the USB charger here, that USB ammeter. And she is still not drawing any current whatsoever. So in theory we should have, let me go down here to the fuse, just to confirm, 5 volts right here. Yes, 5 volts. So what do we have on this capacitor right here? 1.5, that's normal. 2.8, I believe that's normal. 1.5, totally normal. So at the moment, this IC seems to be innocent. At the moment. 5 volts right here. 0.1 volt. I can't remember if it's, seems like that should be 3.3 or something. Man, I can't remember. So maybe that's a problem. We do have a 5 volts right here. Of course, that's the raw 5 volts coming in. Let me check down here around this other chip. Do we have, what do we have here? 0.5. 0.5. So I don't think I'm getting anything down to this charging IC right here. Let me check right here around nearby it. Nothing there. Nothing there. 1 volt. That 1 volt is probably the battery voltage. Let's just check while we're here in the neighborhood. 2.5 is the battery voltage. Okay. That's actually too low for this thing to even try to charge. 2.5. Okay. As memory serves, around 2.93 is the minimum voltage that you can have across that battery that it will try to charge, that the internal charger. So let me, let's see, I have another battery. Let me get my other battery out that I know has some charge on it and see what happens there. Right, let's try this known good battery in here. And see if it will actually turn on with that and maybe charge. All right. Let's see, will she turn on? Wow. That easy, huh? Okay. We look like we're working. Let's see if we will charge with this battery in here. No, we're still not charging. Hope that's coming through. I'm not sure if the glare is too bad, but okay. We are still not charging. So, we don't appear to be. I mean, it's not drawing any current off the USB supply. Fan is kicked on. Fan works. So now that we're up and running, what do we have on the coil down here? 3.95, which is the battery voltage. So now we got to figure out, are we not charging because of the M92 chip or the BQ IC down here? I tend to suspect this BQ chip because that is its job, is charging. This is actually USB-C power management, the M92 chip. Charging is really handled by this IC. That's its job, is to monitor the battery and to take care of its every need. Let's see, is it getting voltage? 3.7. Like, seems like there should be 5 volts coming down here, and I can't remember which pin it's on. As best I recall, there's supposed to be 5 volts coming from a MOSFET. One of these 3 MOSFETs here is supposed to be sitting down. In this case, 5 volts. It could be as much as 15, 19. I can't remember. But it could be a higher voltage, but I've only got a 5 volt supply connected to it, so that's all we can hope to get. Neither one of these chips is particularly warm. Actually, they're quite cold. Which one is it? Okay, guys and gals, we are back and we have made some progress. Let's test this again. Are we charging? Well, let me hook the battery back up. The known good battery here. Right, and then if we go here, 0.47. All right, and if we flip it over, 0.92. She actually turned on that time. So, what was it? It ended up not being either of these ICs. The MT, what is it? Let me get the name right. M92 T36 was innocent, and this little BQ chip down here was also innocent. I kept looking into the connector because I saw something in there, and I'll try to show some video. It's kind of hard to, it's so dark down in the connector, it's hard to see, but there was something in there. Because what I kept noticing was on these USB-C cables, there is a 56k ohm resistor built into these, and that 56k ohms is between one of the the charge control pin, and it's between the DC in this case it would have been 5 volts or 15 depending on what you're running into it, between the supply voltage in and that charge control pin. You should see a 56k ohm resistor, and you'll see it up here, and I'll try to show you under the microscope maybe here in a minute. At the top of this IC, you should be able to measure with an ohm meter 56k ohms approximately. And if you plug this in, you'll see it on one of the pins up here on this IC. If you flip it over, you'll see it on the other. And I could not get it either way. No matter what I flipped it, how I turned it, I would not see that resistance. And I got to think that's probably why it's not charging. It's not detecting that a charger is connected, even though the 5 volts was there. It was still looking for that charge control pin to be connected to 5 volts. So I cleaned and cleaned and cleaned and got something that looked somewhat like candy. It was kind of tacky, sticky, and I used some little bit of water on a Q-tip, because I've learned from watching some other technicians on YouTube that if it's something sugar-based, that water does a much better job of cleaning it than alcohol. So I put some water on a piece of a cotton swab, took the tip off of a cotton swab, a little bit of water, and I cleaned that, and then went behind that and used alcohol and cleaned it out with my tweezers. And when I got through, voila, it worked. So I will try to get you a close-up now of where I was checking for that resistance. Let me just show you the data sheet before we go onto the microscope. You see these pins here, CC1 and CC2, charge control pins, pins 35 and 37 on the M92 T36 IC. That's where I was checking, and I'll show you under the microscope. All right, we're back under the microscope now. Let's take a look at where I'm talking about. Those two pins are here and here. You can see them coming through vias in the circuit board right here. So one here and one here. And what I was looking for was, but I had my meter set to resistance mode, and I was checking between right here, on the fuse, or right. Let me make sure it's in the frame. Right here, or on the fuse, or wherever you want to check on this capacitor. But that's the supply voltage coming in from the USB-C connector. In my case, it was 5 volts because I had a simple 5 volt USB supply I was running. If you had the Nintendo supply, it'd be up to 15 volts. So I was measuring between there and right up here, and I could not see that 56k ohm resistor until after I cleaned the connector, because this is what it's using to figure out which way you've plugged the connector in. Because that tells it a lot. It tells it which pins it needs to drive to supply video to. That the P13 chip on the back drives the video signals out the USB-C, and this helps determine that. And apparently, it will not charge if it doesn't see that 56k ohm resistor either on this pin or this pin. If it doesn't see it to the 5 volts, 15, whatever your supply voltage in is, if it does not see that, it just sits there and looks at you. So that was my problem, just a dirty connector. The pins don't really look damaged on it, just to give it a good cleaning. And I may clean a little bit more to make sure, because there was something sugary, nasty down in there. But yeah, this, and now what I've got to do is, the battery that's in it is down to 2.5 volts. I will use my bench supply and kind of very carefully bring that up. I usually run about 50 milliamps. I put it in constant current mode, maximum of 3.5 volts, somewhere in there, and let it charge that battery up to around 3 volts. Kind of bring it up slow, and then I'll take it off and let the onboard charger take over from there. And it'll probably take it an hour or two to get charged back up. But yeah, this is going to be a pretty simple one, just a dirty USB-C connector. Well, you know it can't be quite that simple. Nothing, it seems, ever is. But I tried this switch in a dock, and it would not dock. I could not get any video out of the dock. And you know, the green light on the dock would flash every now and then. So went back to looking in the connector, and more cleaning, more scraping, and at this point the pin started to come loose in the connector. So it became obvious that it was going to have a USB-C connector replacement to ever be reliable. So that's when we just went ahead and did that. And here's a little montage of a connector being changed out.